Señoras y señores, buenos días. Estoy muy contento de estar aquí esta mañana. Gracias a INER para esta cordial invitación, pero no hablo español suficientemente para una conferencia de 40 o 50 minutos. So we'll have to speak English. Can you hear me well? Whoa, it sounds, we'll make a sound check. I'd like to invite you, okay, I'm going to try this, look like E.T. or so, better? Okay, perfecto. Please come in front if you're sitting behind. There's plenty of room here because we have a rather small screen and we have a lot of sunlight coming into the Palacio de Cristal. So I'm from the Cátedra de Investigación Industrial, and we work as written here, whoops, what happened here? En Tecnología de la Energía y Energía Eficiencia. This is the reason why you can see T3E right here. And if, whether you like it or not, the presentation, and you're interested in knowing what we're doing, well, I recommend that you visit this website, t3e.info, and send us an email. We'll discuss with you. So, this is the title of the presentation, Replacement of Fossil Fuels, the Illusion of Renewables Energy and Energy Efficiency. I'm glad to be here at this premier Congreso, and I hope it will have a long life. Why such a cynical title? Huh? It's very cynical what I say. Well, are we doing a rubbish thing, working hard on renewables energy and on energy efficiency? The answer is no, because I share this thought with Abba Eban that history teaches us that men and nations behave wisely, so we will do it once they have exhausted all other alternatives. And of course, I talk for the whole world here. I don't talk for Canada specifically, the US, the UK, Germany, or Ecuador. So this is how I will make my talk this morning. I will talk about the world and energy. Some of you will find out some figures that they already know, but some others will not. Then I will talk about an example of energy efficiency and show that whether it's great, it's not enough to fulfill our need to slow down the use of the earth we live on. And then I will talk about non-renewable energy, renewable energy, because non-renewable energies are also part of the cocktail that will help us to transit from a fossil fuel society to a renewable society. I will talk very briefly, I will survey something about energy policy and my special topic, energy sobriety. Of course, this applies mostly for OECD countries, or what the so-called developed countries. Maybe we did not develop the right way. And then I will conclude. I use, for most of my presentation, of course, there's a bias. The documentation available in the key world energy statistics of the International Energy Agency and some of a private-owned company that is British Petroleum. So question, how much does humanity consume in terms of energy? Anybody's working on those topics among you, students or prof? You know how many barrels per year, per day, tons of energy we're consuming? My second question, we should know about that. Is this consumption increasing or decreasing? So did we learn something since the Kyoto Protocol, for instance, that was signed, well, a long time ago? Maybe most of you were just babies at that time. And where is the increase and or decrease in energy consumption the most important? You certainly know where the increase is important. Somewhere on the opposite side of the Pacific Ocean. And the decrease, it's the OECD countries, of course. And how the consumption is distributed throughout the world, we see that there are many, many differences. So all the conclusions that I'm providing here are for I would say the north, not necessarily for here. Here, as I said yesterday, it's brand new. We have a tremendous potential. I didn't even thought that there were so many volcanoes around here that you could provide steam, for instance, something that can't be imagined. We have to dig 6 kilometers deep to find some magma in Quebec, so it's not the best place to do it. So let's start with some stats about primary energy consumption. Consumption per capita, very interesting parameter. Reserves to production ratio. I don't want to scare you, but something's going to change, especially the younger ones of you, in the course of your lives, and some future trends. So this should answer the first, I would say the first question. You got the amount of energy we consume per type of fuels from 1987 till today. Well, last year, of course, you don't have the data for 2013. So increase is slowly going on. Did you notice here, as you can see, there's a hole. There's a slowdown in energy consumption. What happened in 2008? We became wise all together, and all the northern countries decided at once to slow down their consumption? No way. That was a couple of guys on Wall Street who did some silly things that made the market went down. So one thing to learn is that the more the increase in the gross national product, the more energy you consume. I mean, it goes together. The economic model, as we know it today, that governs the world, I would say, goes like that. You can't do it. I will come back with that. In this cocktail, in gray here, you got coal, you got gas, and you got oil. That's a lot of energy. And for the rich countries, or for the crazy guys, but they didn't know at the time what to do with the garbage, now they're getting concerned about it. In orange here, you got nuclear power. So there's only a 5% renewable energy. The blue is hydroelectricity. And you're doing good, as I will try to show in a couple of minutes. So we're really dependent on fossil fuels altogether. Remove that, and we're in trouble. From 1990, the year of the Kyoto Protocol, although we got all excited about reducing, well, I would say that more or less there was a steady increase from 9,000 to 12,000, about 12,500 million tons oil equivalent of energy that was consumed in the world. So it never stopped. It goes on forever. It's just as if your banker would tell you, you got a limited amount of money in your bank account, and instead of making some economies, you would still increasing the rate at which you would buy things. This is exactly what we do with the energy. Okay. This is a few words about the regional consumptions for the same resources, coal, renewables, etc. What I want to bring insight on is this here. Whoops, went wrong. Okay, here in Asia Pacific, they consume coal, which is very, very bad. So if you make a little fire at your place and think of carbon dioxide emission, you don't do much difference in the whole balance of the world with respect to Asia. What I want to show, whoops, here is that Southern and Central America is doing very good according to me because you've got some resources. Look at the amount of hydroelectricity you're using. You have, I would say, as far as I'm concerned, a nice balance of energy. A little coal, and the rest, of course, you're pretty dependent on oil and natural gas, but less than other areas of the world. This is a fact, a matter of fact from 2012, which is good. In fact, this information, I'd like to thank Carlos, who went to study with me in Canada once, and he's back here at INER. You in Ecuador consume 70% of petroleum. You have some, so it's a good thing. Some non-hydro renewables, you have so much biomass, I guess, and you have some geothermal. You could increase this part. You also have some hydroelectricity, which is good. And of course, you have some huge power plants, the one I'm going to show later on, and very little natural gas. So I think it's a good balance. It's not that bad as far as you don't depend too much on petroleum. Now I'm going to show you how a nasty person I can be without knowing it. How do we consume energy per capita throughout the world? I will start by my own country. Each Canadian consumes more than 7 tons per capita of energy per year, which is a lot. Ton of oil equivalent for sure. But the good news is that it was 8.4 the first year I gave the course where I take those statistics. So we're improving a little bit, and we're improving not because we're consuming less, as I will show, it's because the population is increasing, but we're decreasing. France, for instance, which is not a bad place to live in, consumes about half as much as Canada in terms of energy per capita. Situation is different, but it is typical of, I would say, northern countries. I went to work in Tunisia, and at that time it was exactly 10 times less energy consumed in Tunisia than in Canada. It doesn't have to do only with the global climate, and at that time Ben Ali was set there, everything was stable. Women were going to university without any problems. I don't want to get to that, to this here, but Tunisia has, well, had universities, government offices, so things were running well with a lot less energy. And then I happened to realize that in Ecuador, you're spending per capita just that amount of energy. So it's fresh for you. Nobody's wasting energy, and even some people do not maybe have access to energy. So it's time to do the good things now so that tomorrow you don't suffer of the wave that is coming. But with those statistics, you have to be careful. In Trinidad and Tobago, they consume more than Canadians. They rely solely on oil, and they're spending a lot of energy. So does Iceland, so does the Qatar and places like that. The amount of people living there is very small. And then, major, I would say, if it's threat or opportunity, but the Chinese, just a couple of years ago, were consuming 1.6 ton of energy per capita. Very important things to see how it's distributed. I wanted to show you that. Now here, the scary picture. You've got the number of years of reserves of energy here. Well, you just take the amount you've got, you divide by the consumption rate of that year, and this makes the prospective amount of energy you can get. For instance, this is 100 years. Well, with a little chance your children, and maybe certainly your grandchildren will live there, well, the world has a little more than 100 years of coal ahead. Something like maybe 60 or 55 years of gas, and more or less 50 years of petroleum ahead. I'll be dead by then, certainly, but you will not. And long before this will go down to zero, something will change. For instance, whoops, look at Europe. Northern Sea has gas and oil, but this won't last forever. Where does Europe will take its energy in 20 years of time from now? Elsewhere. So the balance, the world balance will change, and your petroleum will be in demand. Prices will go up, and that before I die. Well, hopefully. Okay. Now, what is it going to look like in the future? What is RS here is the reference scenario of the International Energy Agency for the prospective consumption. And the 450 scenario is a scenario that would limit the emissions of carbon dioxide so that there would be only 450 parts per million in the atmosphere. This is science fiction, according to Canada, because we're not doing good in that these days. So if you look at 1990, 206, and 215, if it would still go almost linear in the increase, and it was worse than that on the first graph that I presented, this is where we would head. Of course, everybody knows that we're going to slow down, but how much? The two scenarios are the following. Established in 2012, if the increase is on the average 1% per year of energy, well, this is where we're going to end up. And more likely, we're going to have a 2% increase of energy consumption per year, and we're going to end up there. This can be scary, of course, but if we have enough renewable and enough energy efficiency, well, as you can see, energy efficiency is accounted for here, maybe we could do it. But still, in 2030, there will be 75% of all the energy that we will consume that is non-renewable. Here, I cheat a little bit. Huh? I included nuclear, but as far as I'm concerned, nuclear is non-renewable as well. So today, it would be about 85. It would go down, but not by that much, I think. Now, the oil reserves. Why do I talk about oil? Because you have oil. Canada has oil. I could have talked of gas. We have gas. and it's different thing. First thing I want to show is that between 1992 and 2012, the increase of the reserves was 60%. What does that mean? New petroleum was formed within 20 years? No. Reserves means that it's the petroleum that you can get technically and economically. Of course, the resource is more vast than that, but as we develop technology and the subsidies are going pretty much to petroleum rather than solar, despite I don't like it, well, these reserves increase. So consumption increased and reserves increased, and this is why since the Club of Rome in the 1960s, experts always say, well, there's petroleum for about 50 years. If that would have been true, today there would be no more petroleum available, but there's still some. In Central and South America, the interest is the following, is that your share of this reserve went from 7.6% to 19.7%. So here in this region, if you get together, you will have a preponderant role in the years to come in terms of how to use petroleum. More specifically here, this is the same graph that I presented before. You've got about 120 years of petroleum alone here in South America, which is good. And look at the increase. This is this curve right there. From 2007, you discovered a lot of it. So there's a lot of pressure in developing this country. I know we talk about petroleum everywhere on any tribune. Okay, this is Central America. This is something else. Now, these are the figures that were fulfilled to me. I refer to that as, I would say, the Bible or La Torah or the Quran, but this is what I have. From what I read, from what I got, you're producing more than you consume. So you have this possibility to export petroleum, which is good. What I would say, try to use it as less as possible so that you can keep reserves, a balanced economy, and keep it for the future if possible. I'm not the president, I'm not an expert of local politics here, but from somebody who's coming from very far, this is what I would say, because you're gifted, you've got some. But your balanza comercial, petrolia and non-petrolia, shows me that petroleum plays a preponderant role in your economy. So, of course, I'm not Harry Potter here. I don't come with a magic stick and say we're going to do this and that. I'm just telling you, using it, but using it appropriately. As you can see, you were also affected by the crazy guys in Wall Street. What we've got here is the production of petróleo crudo, and what I happen to learn is that your state company is decreasing its production and people from abroad are coming to produce it. I hope they pay enough tax. This is the only thing I'm going to tell you about this. But what I found out also in another presentation is that petroleum really helped people here, as evidenced by this slide. Now in Canada, I want to emphasize on that, we're the 6th largest producer of oil in the world. But there's one characteristic about Canadian oil. It's damn dirty. It costs a lot of energy to produce it. The EROI, or energy return on energy invested, is very low. Conventional petroleum, it might be 30, that is, you get 30 units of energy per unit of energy that you invest. The tar sands, this is what we have. We don't see it very clearly. This is Mexico, this is USA, this is Canada, this is where I come from, and this is 4,000 kilometers west of where I live. This is very far. This is a place called Alberta. It's a provincia. And there they have tremendous amount of petroleum, but it's embedded within sand or soil. So it costs a lot of money to extract it from there and to sell it. It's the dirtiest, well, with some of the Venezuelan oil that you can find. I won't say that much about the way people complain about that, the huge territories that are destroyed because of that. It's amazing. Maybe here you also have a threat in the east about some petroleum reserve. I will discuss that a little later. So now electricity, to complete the panorama of world energy. Why did I pick the electricity? Is because both you and the province I come from have electricity. This is the electricity consumption by region in million tons of oil equivalent for all the regions of the world. And what we can see, I hope I did it, in Central and South America is the fastest growing implementation of it. So it's, for me, it's a good sign. And of course, I think that 20 years from now, all the rivers in Asia will have a dam because they desperately need energy to fulfill their need for growth. So this is Paute Dam, south of Cuenca, in fact, in the Azuay region. I hope I pronounced it correctly. This is a major thing here. I think it's good. I know it had trouble. I don't know the whole story. It had problem to get the water because of droughts. It's about 1,100 megawatts installed, a major asset, because the EROI of hydroelectricity is in between 200 and 250. That is, you're going to get 250 units, or you could, of energy for each unit of energy invested at the beginning. And it lasts, well, I won't say forever, but we've got dams that were built in the 50s, the 40s, and the 30s where I live, and they're still going on. They're going to get 100 years soon. What is interesting as a parallel, this is Manicouagan, Manic 5. There are 4 other dams on the same river. It's in Quebec. Quebec is also a provincia like Azuay, and it's 1,500 megawatts, was built in 68, and it's about the same size. So in Quebec, we also rely on electricity. If you do have some water available, if it doesn't harm the environment too much, of course studies have to be done with that, you should go with this. We're almost energy independent, but cars in Quebec. This is what we have, and I'm sorry, this is 24-point fonts, and I think that at the end you won't get it, but I'm going to try to do something. First thing, I can be proud, we're the biggest electricity producer in the world. We have 60 power plants, 80% hydro. There's only 1 thermal plant left or something like that, and it's very small. We got nearly 37,000 megawatts installed, compared to our closest neighbor, Manitoba, which is another province that has about 5,000. 37 versus 5. This is great. This is the amount of terawatt hours. Sorry, I got problems here. This is the amount of terawatt hours we sold in 2010 for only 8 million people. This is an enormous amount of electrical energy that we're using. We're consuming, we're wasting some of it, I have to say. We did export some energy, and this is important, but what I say is that our peak demand sometimes exceeds our capacity, so we have to buy energy from the States, and we pay for it. So although we export it in the weak periods of consumptions, we have to buy some. And because of that, we realized that our rates, fares, were too low. We have only this of renewable, but I'm going to discuss of renewable because I'm supposed to entertain you about renewable energy. I'm going to tell you about the situation in Canada. Okay, now renewable energies, what is a good thing is that the rate at which we're implementing it is very interesting. It's a very fast pace of implementation, but if you look here, in millions of ton oil equivalent, the numbers are not in the 10,000s. We've got 250, so there's a long way to go before we're going to get enough renewable installed to replace fossil fuel. Here is the situation of South and Central America. Sorry. Pretty good. I mean, of course, the Europeans are in advance, but you're above the world average in implementing renewable energy. This is great. So I'm going to hand up here because I could do a whole course on that, and we could have discussion. Usually when I teach that, I mean, I ask people to go on the internet, find some data and figures so that we can discuss. That was in the International Energy Agency Outlook of 2011. It's quite illustrative. If we don't change direction soon, we'll end up where we're heading. It says it all. We're going to a wall. This is what I think. There are a few signs that the urgently needed change in direction in global energy sharing is underway. So we're doing business as usual. We're implementing energy efficiency, we're developing renewable energies, but we don't think of reducing of energy consumption. And when I mean we, I mean the whole world, and especially the northern countries, not enough. Despite uncertainty over the prospect for short-term economics, what they're expecting, this agency, is that the demand for energy, the new policy scenario, which is their 2% increase, grows strongly, increasing by 1/3 from 2010 to 2035. What it means is that they're realistic. Although we have a limited amount of energy on a finite volume, which is a sphere called Earth, we're going to continue increase the pumping of that energy, fossil fuel energy. Okay, I'm going to talk about renewable energies, and the situation I'm going to discuss is that in Canada. Does energy efficiency allow Canada to reduce or maintain its energy consumption to a stable level? This is one question we may ask. How's it going, okay? With respect to time, we're consuming some energy. Then we implement energy efficiency. Are we able to stabilize our consumption? Are we able to make it decline? The next slides will tell you. How much energy efficiency would it take to stabilize Canada's consumption, for instance? So I'm sorry, this shows my French roots. I took it from a French report, but the trends are important here. This is the amount of energy we consume with respect to time starting in 1990. The red curve is the energy that we would have consumed provided nothing would have been done. The blue line is the optimistic curve, or is the reality. We limited the increase of energy to 1.5 over that period, 1.5% instead of 2%. So we're below the reference scenario of the International Energy Efficiency. Good. So, good for us, but energy efficiency measures should be multiplied by 4 to stabilize the consumption, to have a flat line on the graph. We should be 4 times more aggressive just to make sure that we maintain our consumption to a constant level. I didn't say to reduce it, just to maintain it. However, we will have to do without 85% of our actual resources, and we're still expecting to depend on 75 of, well, I said fossil fuels, this is not totally right. I should include nuclear power into that by then. So for me, of course, it's a good step to do some energy efficiency, but suppose you have a swimming pool that is filled with a 10 inches pipe continuously, and you have a teaspoon trying to empty it. Eventually, it will overflow. This is exactly the opposite problem that we have here. We're consuming. We're reducing the consumption, but not enough. You're on the highway. You run at 140 kilometers per hour, and then there's a curve, and it says, you better slow down at 50, and you slow down at 135. You may end up in the paysage. Okay, the other thing. How much time would last Arctic oil reserves if the world only had this oil to consume next year? Because, you know, we're going to find some more energy. As I said, we're discovering some every year, and some is becoming available every year. I said 60. Why did I choose Arctic oil? It's because our Prime Minister spends 1 week of vacation there per year, because this is the biggest known reserves that has not been touched yet. This is a big reserve. How long would last the field of Yasuni National Park, for instance? I got some data from France, so I tried to figure out what it is. And then finally, how long would last the total Lakewater's actual oil reserves? About 7.2 to 8 billion barrels. This is what I found. It's in between those two. All the sources don't say the same thing. Okay, I don't know if you can see this figure. It's too bad, but in the middle here, you got North Pole. In dark brown, you got the reserves. And the total of that is an incredible, well, if you can see that, well, wow, you're really good. Sorry. 63.5 billion barrels of oil lay down beneath the Arctic Ocean. This is an incredible amount of energy that 5 countries fight for. Federation of Russia, Los Estados Unidos, a small country not far from here, Canada, Denmark, and Norway. A Russian diver went way down the sea to plant a flag of Russia, just to claim that North Pole was Russian and stuff like that. People go banana over that. Does it worth it? How long will that last? And this is Yasuni National Park that a lot of people look at, saying that we're going to exploit it, should we or not. I know that was a big debate. I don't want to get into it. I don't know how the political and economical issues with respect to that, but we're going to look at it from a foreigner perspective. Okay, total reserves in Arctic, 63 billion barrels, or about 9,000 million tons. This is a lot of oil. But the consumption in 2012, according to BP, was above 4,000 million tons for that year, for the whole world. And if you look at the key stat that just got away, you can get that on your smartphone if you want. It's even more. So I made some scientific calculation. I divided this by that, and I came up with 2.2 years. So provided there would be no more oil on Earth, this would last for 2 years. What's the point here? It's not 20, it's not 200, it's not 2,000, it's 2 years. 2 years. That is, we're urged to act, do something, reduce the consumption we do have. We don't see it, you know? Till the banker calls you and says, we're going to take out your credit card, you do nothing. You keep going on. This is exactly what we do. Whoops. Now, I will try to go with the total reserves of Yasuni National Park. What I read is 150 million barrels, or 0.85 billion barrels. The duration would be 11 days. What I say is that, with respect to the world, it would make no difference. So use it wisely and carefully. Total duration of Ecuador's actual reserves, I take the figure of 2011. I took the 7.2. I read another one which was 2. The idea is the order of magnitude here. 3 months. So keep it. Use it wisely. This is what I conclude from that, from a foreigner. Now my next question is, which renewable energy hydro is mostly implemented in Canada? Would that be geothermia, eolia, biomassa, solar? Okay, we're going to go with a survey here because it's getting boring. Who thinks it's solar? Okay, 1 people. Who thinks it's the other one next is biomassa? Right, 1 minute. Eolica? Getting better. And geothermia? You get it right on. It's eolica. It's I'm gonna tell you when I'm gonna show you the slide. Whoops. But my question here: by which factor should we? It's the same exercise. Should we multiply the implementation of this source of renewable energy to stabilize the Canadian consumption over the next few years? Same question. The increase is 1.5% per year. We'd like to flatten it. The gap in between would be compensated by wind power. How can we do that? Oh, you don't see the numbers here. In 2012, there was 5,000 megawatts installed. In 2013, 6,000 megawatts installed, for a tremendous increase of 20% throughout the country. So this is definitely the most implemented energy. 6,000 with respect to 66 solar. Solar is not there. We're not in the ballpark here. Okay, so I do some fancy calculation once again. That was the consumption of energy in 2007 in terms of gigawatt hour, because we're talking of electricity production. It's about 3 million. Then the assumption is the International Energy Agency projection for 2% increase with their reference scenario. So that would be the consumption in 2030. So the increase is nearly 800,000 gigawatt hour of electricity needed produced by those windmills. So then to keep the consumption of fossil fuels, as I said, in 2030, this is what we will need. Then I'll go with a simple calculation once again. This is what we had in 2013, assumption, my God, what's happening here? Oops. A penetration of 30%, energy needed in 2030, this more implemented, okay? The wind power required by 2000, tried many things. Many countries tried many things to try to implement renewables and try to implement energy efficiency and to reduce our consumptions. Not really. Subsidies for projects, feed-in tariffs. The Germans were the first to do it and they did a great thing. Nowadays they have a lot of solar power installed and a lot of wind power as well. Restrictive legislation, we've got some, but not too much. In Canada, we have huge conglomerates, huge enterprises, multinational, like Rio Tinto, Alcan. And when they discuss, I would say, the amount they will pay for energy, it's not with the government, it's with the Prime Minister himself. And they say, well, we want to pay this, otherwise we go out of the country. This is how it goes. Same with pollution, same with everything. So the restrictive legislation doesn't work really well. Royalties, I hope that all those foreign companies that come here in Ecuador and exploit your resources are providing some royalties on what they're doing. We're having a big debate on the mine industry now in Canada just about this royalty issue. Taxation is another issue. We're paying our gas about $1.25, 30 per liter. I think that here it's about 50 cents, and in Europe it's 2.30. I think that the difference is mainly taxes. And here I know there's some subsidies, but I don't want to get into that. I'm going to finish with some example of what I think is not necessarily sustainable. I was going through the Wall Street Journal this last spring, and I found out that there's a new business between Europe and the States. Europe, they want to be green. They want carbon neutral energy production. So they want wood pellets to feed their biomass power plant. So they're buying that in the southern states of Florida, Georgia, Alabama, Virginia, and North Carolina. As you can see, in 2007 there was nothing, but these days what you have is close to 1.8 million tons of wood pellets, chips of pellets. The forest of the southeast United States is going to Europe to be burned to produce electricity. So if you make a control volume around Europe, it looks very good. I mean, their balance is nice. But what will happen with the forest in the States? What I don't know, I'm not a specialist, but this is a huge amount of energy and it's increasing. So I'm afraid that one day we're going to waste our resources. Energy sobriety, a little more bizarre topic here. What is it? The definition is simple. To implement it is completely difficult. It's an approach to energy management that aims to reduce energy consumption, at least to reduce, by influencing the behavior of energy users, to adapt a good behavior. But as far as we're concerned, Canadians, we've been wasting energy for centuries, maybe 1 century. We'll have to change a lot to have a significant impact of energy sobriety. So is this an individual or collective action? I think that we should start one person after another, and then one organization after another, and eventually one country after another, and all together we're going to make a difference there. How to ensure sustainable degrowth is my question. If I would try to be elected as a president of anything and suggest that the economy will go down, I would be either crucified or, more simply, in a democracy, not be elected. But we'll have to go there. When I say sustainable degrowth, I did not invent anything. These issues have been discussed since the 1960s. But more and more people think that this is the only way to go. When I say sustainable degrowth, that is, I don't want the economy of the world to collapse and people to suffer, but things to slow down as much as we can. And, well, it has some philosophical issues behind that I don't want to discuss that, but as we saw on the first slide, or one of the first slides, in 2008, there was a stop in growth and there was a stop in natural resources consumption. I don't know if there was a stop in happiness in the world. People suffered for sure, but what we'd like to do is to end up the circle here. More growth, more use of natural resources, and more happiness. I don't think it's really connected. Happiness doesn't have to do with all of that, but this is another issue again. The unidirectional progress model is the following. It's linear, and you got a predictable future when you think that the only way to progress when you're at 2, because you were at 1, is to go to 3. This, unfortunately, has a little mind-opening. We always act as if progress goes along with increases, but it will not be possible. Progress will not come from an increase in natural resources consumption, sure. Any movement on the side today is acknowledged as eccentric. When I talk about that, I was in a Chamber of Commerce. Can you imagine how many tomatoes people threw at me when I was discussing that? Okay, I know you're from a university, you're flying in the clouds, you don't think? No, I really think it's the way to go. And I think that multi-directional progress is the only way we can go through. So it's not forbidden from one point to go back and say, well, we made a mistake, and we're going to start a new basis to define the progress. And I think we'll have to go that way. All movement on the side is acknowledged as possible, acknowledged as a progress. The mind opening is 360 degrees, and of course it takes a lot of energy to say that what we have today may be compromised, or really compromised if we continue to do the things as we did. My concluding remark, they mostly apply to the world. Don't think I'm stupid enough to be the advocate of no energy efficiency or no renewable energies. No, that's not the case. But what I say is that the amazing increase of energy efficiency, the new sources of fossil fuels yet to be discovered, as I mentioned, the frenetic development of renewable energy technologies, more restrictive energy and environmental policies will not compensate the increase of energy consumption, the fabulous increase of Asian economy, which I did not discuss, the vanishing of more than 85% of our actual resource within a century, the lack of lucidity with respect to the situation, certainly, and the lack of political courage to enforce what should be done to soften the upcoming blow, just to soften it. So that's it. I would say, well, you won't see it, unfortunately. This is the map of the world. This is where we have some links, and I would like to develop one right here on the red spot with Ecuador if possible. So in the future, I don't know with who I will work with, but if you ever want to discuss this issue, other things, or partial differential equations, I do that as well. I'd be your man to discuss it. So gracias por su atención. Un placer de estar a su servicio.
Ok, muchísimas gracias al Dr. Rousse por su conferencia magistral. ¿Tenemos alguna pregunta dentro del público? Sí, ok, entonces ya le vamos a llevar el micrófono, por favor.
Carlos, I think I may need you. S'il te plaît.
Hello, my name is Rolf Renziok. I'm from Germany, University of Rostock. Thank you very much. Okay. Thank you very much for your interesting presentation here.
Opinion or your comment more about the importance of life cycle analysis related to the topics of energy efficiency and renewable energy. I think it's very, very important that people here know about the importance of that.
Yeah, it is. It is really important. I was glad this fall that the Quebec government, or provincial government, they gave 60 researchers $2.5 million in grant to form a huge network. Before there was a small one, and I was very happy for them because this is their business to do that. We really have to think of this life cycle analysis. Like I said on one slide, I didn't have much time to do it, but when wood pellets go from the United States to Europe, if you limit your analysis geographically to Europe, I mean, it's a good thing. I mean, they're carbon neutral, but you have to build plant in the States, you have to destroy the environment to do that. We usually blame the Amazonian forest or area to do that, but now it's happening right there in the States, and we're passing some similar laws because our pulp and paper industry is going down because of tablets and PCs and all of that. So the industries, they don't know what to do with that, and we're thinking of this. But we're not thinking globally in terms of the planet, I mean geographically, and in terms of time. Life cycle analysis, I think, is the way to do. I tried. I think that Carlos had left the chair at the time. We discussed that, but there's a board, advisory board with my chair, and we're trying to have the students within their master's and PhD students to at least think about it and discuss it, just a couple of pages. I don't want them to be experts in that because it's difficult. I mean, we're mostly building things, but we have to keep in mind that, of course, you're still young, but I'm getting older. Maybe I won't see the big collapse of everything, but remember, 20 years of gas and oil in Europe. This will squeeze the way the fluxes of oil is actually going, and so we have to think global and in space, and we have to think also in time, because petroleum is renewable, but it takes a couple of million years, and we'll get there soon.
Ok, muchísimas gracias al doctor Daniel Rousse. Le invitamos al ingeniero Marcelo Aldeira, quien hará un reconocimiento al doctor Rousse. Por favor.
Gracias. Marcelo.
Felicitaciones, muy interesante la conferencia y creo que esto nos debe hacer reflexionar cada vez más. Y ojalá de aquí, que es uno de los objetivos de este evento, salgamos todos como unos misioneros a difundir entre nuestras familias, nuestros amigos, nuestras personas conocidas en los trabajos que hacemos, para que vayamos a esa sobriedad energética que decía Daniel y que dejemos el consumismo, porque de otro modo nos vamos a dar contra la pared muy pronto. Y yo quisiera que la entrega de este presente no la voy a hacer yo, sino pido a Carlos que por favor, como brillante alumno de Daniel, pues tenga la bondad de entregar.
Gracias por su invitación, Carlos, Andrés. Muchas gracias. Great.
Okay.
Hacemos investigación para el futuro. Lo mejor está por descubrirse.